All right, in our previous biology bite, we learned that sets of 3 nucleotides in our mRNA are codons, and that each codon can refer to an amino acid, and that some codons are start codons and some codons are stop codons. Now, I said plural with start codons. There is only one start codon. AUG is the start codon. It's always the start codon. So, interestingly enough, all amino acid all proteins, their polypeptide begins with a methionine. That's kind of cool. There are 3 different stop codons, as we can see in the table: UAA, UAG, and UGA. Another cool thing to note in the table is that you can have multiple different combinations of codons that translate into the same amino acid. So that's kind of cool. UUA, CUU, CUG, those are all quite different for various definitions of different, but they code for the same amino acid, right? If you want to see a more dramatic one, here's all the UC blank codons. They all code for serine, but then over here we have AGU and AGC also coding for that. So our question that we left off with was, if tRNA is what is actually carrying the amino acids that the codon codes for, how does tRNA know what amino acid to bring to what codon? How does tRNA know to bring methionine to AUG? Right? Because there is a tRNA circling around, holding methionine. All right, so here's our tRNA, and it's attached to methionine. How does it know to bring that to AUG, huh? And the answer is actually very simple, right? Because nucleotides base pair, right? And tRNA is RNA, so A to U, G to C, right? So if tRNA needs to bring, if this tRNA that's connected to methionine needs to connect up to AUG, all it has to do is have UAC. So here's my tRNA with its UAC carrying methionine, and here's my mRNA with its AUG. And what do you know? These guys can hydrogen bond to each other. So if this is our mRNA codon, then our 3-nucleotide combo that can connect to the codon is the tRNA anticodon. So this is why tRNA can be specific to an amino acid that... This is why tRNA can bring a specific amino acid to a specific codon, right? Then the next one was ACA, which coded for threonine, which means that our anticodon, right? So our anticodons would be UAC, then UGU, and then GUG, GUA, or GUT. Oh, yeah, GUA. And then we'd have CUC, UGU, and GUG, and then there's no anticodon for stop, because an anticodon is on tRNA, and tRNA carries amino acids, and as we mentioned previously, stop codons do not code for amino acids. Stop do not code for amino acids, which means there is no tRNA for a stop codon. Important notes. So, not too bad. Now we know why a tRNA can bring a specific amino acid to a specific codon. tRNA itself has anticodons that can just hydrogen bond up to the codon. And next up, we'll talk about what goes down at the ribosome in our next Translation Biology Bite. Woo-hoo-hoo!